All right, welcome back. So we talked about what a mineral is, how it's made up of different elements and compounds. Now, when we're looking at a mineral, we can describe it in various ways, and those are the characteristics of the mineral. Different minerals have different characteristics. It allows us to identify them, name them, figure out what they are. So the first characteristic when we're looking at a mineral is something called luster. How does light reflect off of a particular mineral? And we usually break it down into two categories: metallic luster or non-metallic luster. Metallic luster in that it's shiny like metal. Non-metallic luster meaning it's not shiny like metal. You know, when I'm talking about metal, think about, like polished chrome, shiny like metal. Everything else is non-metallic luster. There are different categories of non-metallic luster, but the easiest way to break it down is just, does it have metallic luster, shiny like metal, or not? Then we look at something called cleavage. Cleavage is the ability for a mineral to break along preferred planes. It's how a mineral breaks. So some minerals exhibit good cleavage. They can break into flat planes, it's one direction of cleavage. They can break into kind of parallel kind of cubic sides. That's called two directions of cleavage. They can break on all three sides to form what looks like cubes or boxes. It's three directions of cleavage. Sometimes the things are nice and neat and parallel and perpendicular, but sometimes, things are slanted a little bit. So you can get, for instance, three directions of cleavage, but just a little bit of slanted. You can get four directions of cleavage. So again, it's how a mineral breaks. Because of the atomic structure of these things, when you smack certain minerals and when you break them, they break into these nice, neat little planes. Sometimes they don't. Sometimes you hit a mineral and it just breaks into nothing. That's called fracture. When a mineral breaks with seemingly no planar pattern at all. You don't see any flat sides here. They're just kind of all over the place. There's no pattern in their breakage. Streak is another characteristic we can look at. Streak is the color of the powder left behind on a porcelain streak plate. That's this little white square thing when the mineral is scraped across it. So what you do is you take a mineral and you kind of just like color on this porcelain streak plate, and the powder left behind is called the streak, and it actually indicates the true color of the mineral itself. Some minerals, for instance, on the right, this is the mineral hematite. It's kind of this reddish brown. Its streak is reddish brown. Go figure. But look over here. This is also hematite. It's kind of this shiny and black, silvery mineral. And when you streak it, oh my goodness, another reddish orange brown streak. So streaks show you the true color of a mineral. In this case, these two minerals have the same streak because they're the same mineral. It's just kind of different varieties. Hematite, hematite. So, different minerals have different streaks. Color. When we're looking at a mineral, we can assess its color. Now, typically, color is the least useful thing in identifying many varieties of common minerals. Because, excuse me, I don't know where that came from. For example, this is a mineral fluorite. You can see, you get purple, yellow, lighter purple, clear, kind of like a grayish color. So fluorite comes in different colors. In some cases, there are other minerals that one single sample has a bunch of different colors in it. Same thing over here. So color can kind of be misleading. Color can be very misleading. I mentioned in the previous video, talking about quartz, the most common mineral on Earth. It comes in clear, white, pink, purple, black. So don't rely on just color, like, oh, this is purple, so it must be this thing. No, not necessarily. It can be helpful, but it's more likely than not the least useful. Hardness. Hardness is another characteristic of a mineral that we can look at to describe a mineral and helps identify them. Hardness is defined as the mineral's ability to resist scratching. So if I have a mineral, if I try to scratch it with all this different stuff, will it scratch it? And minerals are, the hardness is ranked on a scale called the Mohs hardness scale from 1 to 10. So 1 being the softest mineral, meaning anything can cut this mineral tough. In fact, you can take your fingernail and just kind of scrape lines into it because your fingernail has a hardness on the Mohs hardness scale of 2.5, which is harder than talc. You can do the same thing with gypsum. But for instance, fluorite or quartz, you would not be able to scratch with your fingernail because it is softer than those things. So this is a scale that relates, again, hardness. That's not strength. For instance, if I look at the hardest mineral on Earth is diamond. Nothing can scratch a diamond except another diamond. So, fun fact: if you have a diamond ring and you take like a steel nail and you scratch it and it scratches your diamond, it is not a diamond, ladies and gentlemen, because it's the ability to resist scratching. The only thing that can scratch a diamond is another diamond. So we're talking about that as far as hardness. Strength is something different, because even though diamond is the hardest mineral, if I took a diamond and smacked it with a hammer, well, I'd just crush it. I mean, it would just crush to nothing. So strength and hardness are two different things. Again, hardness is the ability to resist scratching. Oftentimes, what we do is use what's called a little glass plate in geology. Again, we do a lot of this in 101, Geology 101 here. But it's a little glass plate, and we take a mineral and we see if that mineral can scratch glass. So if it has a hardness less than about 5.5, which glass has a hardness of, for instance, minerals like apatite, fluorite, calcite, gypsum, and talc, it would not scratch glass. I could scrape it on this glass and it wouldn't scratch. Or if you take any of these and go to your car window or your window at home, it would not scratch. But for instance, if you take quartz, which is a very common mineral, you take quartz and you kind of scrape it on your car window or your window at your home, it will scratch. It will scratch your glass. It will scratch. Fun stuff. Another characteristic that some minerals exhibit is called fluorescence. So some minerals will fluoresce, glow, when exposed to ultraviolet light, UV light, black light. This is the same type of light like if you go to a haunted house or if you're up in the club and you go and your shirt's glowing, like a kind of a weird color. It's because of the black light. It has to deal with the energy form of ultraviolet light exciting atoms, and when the atoms get excited, they jump up energy states, and when they come back down, they release that energy in the form of a glowing light. It's a whole physicsy type thing. But just know, some minerals under ultraviolet light will glow. For instance, all of these different substances down here, when you turn on shortwave ultraviolet light, you can see how they kind of fluoresce all these different colors. For instance, look at the big difference here, right? So you see it's kind of like a whitish pink, maybe a little bit of brown stuff here with these black chunks in it. Well, the black chunks don't really do much, but the pink stuff turns orange, the brown stuff turns green. Interesting stuff. And then there's many other characteristics that can help us identify minerals, helps us differentiate minerals. One of them is something called birefringent. When you look at an object through certain minerals that are birefringent, you can see a double image. So this is the mineral calcite, and you put it on, for instance, this piece of paper with some writing on it, and it looks like you have double vision. So that's what being birefringent means. Some minerals are magnetic. They're attracted to a magnet, maybe weakly, maybe very strongly. But not all minerals are, but some are. Some minerals have an acid reaction. You drop a little diluted weak hydrochloric acid, that's HCl, hydrochloric acid. You drop a little bit of weak stuff on certain minerals and it will begin to react. It will fizz and bubble and effervesce. Not all minerals do that, some do. It depends on their chemical composition. And taste, yes, taste is a characteristic. A few have a very distinct taste, some good, some not so good. There's been often times I've been out in nature and I'm just out there licking minerals and licking rocks to try and identify what's going on. So that brings us to the end of these characteristics. So when we come back, we'll talk about, now that we've discussed minerals, how to describe them, what they are, we'll talk about the difference between those and rocks. So I'll see you back here in just a minute.